Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to my channel, The Baloch Scholar. So today I am starting another topic of class 9th physics, that is velocity. That is velocity. So it is a topic similar to speed, but speed shows the magnitude. This shows direction and magnitude both. Okay. Velocity is how fast an object is moving in a particular direction. Means how fast a body is moving in a particular direction. Suppose we have a car on a road that is moving the speed of 100 kilometer per hour, but in moving in the direction of north. Okay, so how fast an object is moving in a particular direction, because velocity is the vector quantity, it is magnitude and direction both. Okay, let's come towards velocity. The time rate of change of displacement is termed as velocity. Means in how much time, how much displacement is covered. This is called velocity, or you can say rate of change of displacement is called velocity. The time rate of change of displacement is termed as velocity, and this means in how much displacement is covered. Suppose we have an example of airplane. See this airplane velocity 500 mile per hour towards west. This plane is moving for around the velocity of 500 miles per hour towards west. Okay, it is direction, magnitude also, directions also. Okay, so it is the distance covered by a body in unit time in a particular direction. Means if a body covers the distance in a unit time and in a particular direction, this is called velocity also. It may be emphasized the magnitude of velocity is equal to speed. The magnitude of velocity is equals to speed. Means whatever the magnitude of velocity is, that is equals to speed. I already told you that speed shows the magnitude, but velocity shows magnitude and direction both. Thus, velocity can also be defined as speed of an object in a particular direction. Means speed of an object. This is speed of the airplane in a particular direction. See, what is the speed of this speed or velocity of this aeroplane? 500 miles per hour in a particular direction towards west. Okay, thus we can generate its formula. Velocity is equal to displacement over time, rate of change of displacement. Okay, over time, or we denote velocity by v is equal to displacement d over t. Okay, this is the formula. As you know, velocity is a vector quantity. Vector quantity, what is vector quantity? Which has magnitude and direction. Magnitude and direction both. Okay, see, this is 500 mile is the magnitude and towards west is the direction. So its SI unit is meter per second. Okay, the SI unit of displacement is meter and time is per second. This is, it is very common to use the velocity in units of kilometer per hour. You can also use the velocity in kilometer per hour. I already told you the speed of or velocity of that car is 100 kilometer per hour. Okay, although it is non-SI unit, although it is non-SI unit. Okay, let's come towards the uniform velocity. Uniform means same. Okay, this means same velocity. Means if a body is covering equal displacement or equal distance in equal interval of time, means if a body is moving through A to B, this is A, point A to B, and it is, can say, in short intervals of time, so it is in same speed. It is in same speed covering equal displacement and equal interval of time. A body has uniform velocity. A body or an object has uniform velocity if it covers equal displacement and equal interval of time. However, small these intervals may be. Means these intervals can be small. Okay, time intervals can be small. These I told you, starting from point A with small interval of time reaching point B. So in this, the body is covering equal displacement and equal interval of time. The velocity is same, okay, and uniform. For example, a car moving along a straight plate road with constant speed in a specific direction. Suppose you are in motorway, we can say in motorway road, motorway. So there the speed limit is 100. Okay, speed limit is 100 kilometer per hour. So you are in this constant speed moving towards a particular direction, means you are in uniform you are having uniform velocity. Okay, let's come towards the non-uniform velocity. Means and before that and uniform velocity we add same velocity. Means for example, a point A, body is moving from point A to point B. Here in non-uniform velocity, for example, in short interval of time, the speed of the body is 5 meter per second. After, can say, short interval of time, the speed of the body is 8 meter per second. Okay, this means the velocity of body is changing. Velocity of the body is changing. Okay, so in uniform velocity, the velocity of the body was constant. Okay, but here in non-uniform velocity, the velocity of the body is changing, okay, in interval of time. So this means a, a non-uniform velocity, a body is said to be a non-uniform velocity if it covers unequal displacement. Suppose this is a body covering displacement, unequal displacement, having a direction. So car is there moving in short interval of time, it is changing its speed. Okay, so a body is non-uniform velocity if it covers unequal displacement in an equal interval of time, or you can say equal displacement in unequal interval of time. If displacement is unequal, then your time is it is equal interval of time. If it is equal displacement, then unequal interval of time. Okay, suppose we have a, can say, example, drop a stone from the top of a tower or tall building and observe its motion carefully. When you drop a stone from top of a tower, you observe its, you can say, velocity, or what is the speed, or in what speed you throw it, and in what time it reaches the ground. Okay, you will observe that it covers unequal displacement and equal interval of time. Okay, so thus motion of freely falling objects is an example of uniform velocity. This means the velocity of the body is changing continuously after the short interval of time. So when you throw a stone in a height, so it velocity changes after interval of time. Okay, so this is non-uniform velocity. Okay, now let's come towards the uniform velocity, average velocity, that is. So here I am supposed to find the average velocity is a non-uniform velocity. My definition was a body is non-uniform velocity if it covers unequal displacement in equal interval of time. Okay, here suppose a car is there. See the example, a car is there that covers displacement, can say, 20 kilometers in 1 hour. Another 1 hour it covers 10 kilometers. Okay, in 1 hour plus per 1 hour it covers 20 kilometer displacement, and another 1 hour it covers 10 kilometer. So the here it is motion is non-uniform. Okay, non-uniform velocity is there. So I want to find the average velocity between the displacement, okay, covered. So here I will be using the total displacement covered over total time. So I will write the total displacement. What is the total displacement? 20 and 10. Okay, then I will can say take it out. Total time. Okay, total time. So I will get my average velocity. So average velocity is if a body covers unequal displacement an equal interval of time or equal displacement an unequal interval of time, then we use the term average velocity to describe its motion. So I already told you this is the definition of non-uniform velocity. So for finding its speed or velocity, average speed, to describe its motion, so I need to find the term and use the term average velocity. So the average velocity is defined as the ratio of total displacement covered by a moving object. Means if our moving objects cover total displacement and total time taken, okay, and total time taken. Average velocity is denoted by VAV, average velocity, total displacement cover over total time. This is the formula. VAV, you can say displacement T, okay, over T. Okay, let's come towards another topic, that is acceleration. So acceleration is the rate of change of velocity with respect to time. Means changing the velocity with respect to time. If you have ridden a bike, or you can say drive a car, so you have seen a accelerator where you increase your race, okay, bike can say speed, where you increase your bike velocity. So suppose you are doing a race with your friend, and your friend is moving forward than you, and your friend is moving forward than you, so you will increase your bike race by putting the accelerator. So your velocity of the body or bike will increase with some second. Okay, within 10 seconds the speed of your bike will increase. Okay, then you will cross your friend. So suppose you can say in a car, you're traveling, so you will put the accelerator and you will increase the velocity. Here the rate of change of velocity will change, okay, with respect to time. Okay, see the example in the present in the book. Suppose you are traveling from Rawalpindi to Lahore by train, which is moving at constant velocity of 16 km per hour. What will happen if brakes are applied by train driver? Sorry, the velocity of the train will start decreasing, and ultimately it will come to rest. Okay, means if you're traveling from Lahore, Rawalpindi to Lahore in a train, so and a speed at the speed of velocity of 16 kilometer per hour, so it is having direction also, magnitude also, so velocity is there. So if the train drivers push the brakes, so train will not stop directly. So with the passage of time it will come to rest. Okay, first it will start decreasing its velocity, then it will come to rest. Suppose the speed was at 60, so at first it will come to 40, then 20, then 10, then it will come to rest. Okay, so it will take some time, okay, for changing its velocity. So that is why acceleration is rate of change of velocity. So velocity of the train will start decreasing, ultimately it come to rest. Okay, what are the initial and final velocity of the train? So what can be the initial and final velocity of the train? Okay, what was the initial velocity of the train? 60 kilometer per hour. So what can be the final? So final is 0 kilometer per hour, mean it will come to rest. The final velocity, initial and final velocities of the train are 60 kilometer per hour and 0 km per hour respectively. Okay, I already told you, means if the initial velocity is 60 km per hour, so with the passage of time, interval of time, so it will start decreasing. At first it is 60, then it will become 40, then it will become 20, then 10, then it will become 0. So the final velocity will be 0. If the train takes 5 minutes to come to rest, then it can be said that the velocity of the train was changing during this time interval. I told you now the velocity of the time is changing. Means if before it was 60 km, then it will be 40, 20. With the passage of time it will get decreasing. It will start decreasing. Okay. When a body is moving with velocity which is changing either in magnitude or direction or both, then the body is said to be moving with an acceleration. The rate of change of velocity with respect to time is known as acceleration. So acceleration is denoted by a. So the formula can be written change in velocity over time taken. Okay. So you can also write that acceleration is equal to final velocity minus initial velocity over time. So if you want to find out the acceleration of a body, so first of all you will can say minus the final velocity with the initial velocity over time, then divide it with time, so your acceleration will be find out. Okay. Okay, see here. Okay, Vi is the initial velocity, Vf is the final velocity, and T is the time taken to produce the change in velocity. So acceleration is the vector quantity. It is a vector quantity which is direction and magnitude both. The SI unit of acceleration is meter per second. It is meter per second. Okay, SI unit is meter per second. Okay, come towards uniform acceleration. That is, so first of all, I will make you understand with the example. For example, a body, it is A, point A, starting from point A to B with this time intervals. Means if a body is traveling from point A to point B with the time intervals, but the change in velocity in this interval remain same. Okay, remain same. Mean it is a constant velocity. Can say with the short interval of time. So it means the body is said to be an uniform acceleration. The body is said to be an uniform acceleration. Okay. Okay, this means if a body is traveling from point A to B in short interval of time, but the velocity in this interval, the velocity of that body will remain constant. So this means the body is an uniform acceleration. See here, if the velocity of a body changes equally in equal interval of time, however, small these intervals may be, then the body is said to be moving with uniform acceleration. So that is why I made you understand with the example. See, the body is moving from point A to point B. In these intervals, small intervals, the velocity is same, can say in these intervals. So this means it is an uniform acceleration. If the velocity of the body is increasing with time, then the acceleration is taken positive. Means if the velocity is increasing with time, it is taken as positive. As I gave you the example of the car, by putting the accelerator, so it will we can say increase the velocity with time, with passage of time. So it is taken as positive acceleration. The direction of positive acceleration will be same as that of velocity because it is increasing, the velocity is increasing. See, next, if the velocity of the body is decreasing with time, means if the velocity of the body is decreasing, as I gave you the example of train, if the velocity of the body is decreasing, then the acceleration is taken as negative. Then acceleration will start decreasing, means it will be considered as negative. In this case, the direction of negative acceleration will be opposite to the direction of velocity. Means the direction of negative acceleration will be opposite to direction of velocity because velocity will be decreasing. Velocity will decrease. Negative acceleration is also known as deceleration or retardation. It is also known as deceleration or retardation. Okay. Okay, come towards non-uniform acceleration. Here, if a velocity of a body does not change equally in equal interval of time, does not change equally in equal interval of time, however small these interval may be, then the body is said to be with body is said to be moving with non-uniform acceleration. Okay, suppose see the example. A body is moving from point A, this is point B, traveling from point C. Okay, here. Okay, the time interval. Suppose the time interval is same, 2 second. Here it is also same 2 second. Here also 2 second. But here in this interval, okay, the speed is 10 kilometer per hour. Okay, here the speed is 16 kilometer per hour. Here the speed is 21, can say 25 kilometer per hour. Suppose the here the speed velocity is changing but in different pattern. Velocity is changing but in different pattern. The time interval is same. Okay, same. In 2 second it is 10 second. Can say 10 meter per second. In another 2 seconds, 2 seconds it is 15 kilometer per second. Another 2 seconds it is 25 kilometer per second. Means the pattern of the velocity is different. Okay, it is not a straight road. It is not a straight road. Okay, before the case was different, the road was straight. That is why we can say the velocity was 10 kilometer per second, then 20, then can say it was sequence wise. But here the road is not, can say, straight, so the pattern of the speed will be different. If the velocity of the body does not change equally in equal interval of time, the time interval is equal. However small these changes, these interval may be, then the body is said to be moving with non-uniform acceleration. If you are traveling in a hilly area, mean in mountain area or hilly area you are traveling, then you will observe that the road is not straight. I told you the road is not straight. In some places you will increase the, you can say, speed velocity. In some places you will decrease the velocity. Okay, you will change the pattern of the velocity. Road is not straight for all journey, but have several turns and slopes. It is not possible to drive with uniform acceleration on such road. So it is not possible to drive with uniform acceleration or same velocity. Thus, the motion of a vehicle in a hilly area is an example of non-uniform acceleration. Is an example of non-uniform acceleration. Okay.